Well, hi, good morning, and thanks so much for joining me in my shop here. It's March 8th. It's been a couple days since I've been in here, and the reason is the weather. The weather outside is just fantastic. Have a look out my window here if you can. Beautiful sunshine out there. Temperatures are unusually warm, and it's pretty tough to come down in a windowless shop here when I know it's so nice outside. So what I'm going to do, after thinking a bit about it, is I'm going to eliminate the battery supply from this radio. I'm going to trim away the wires and the leads and stuff like that. And I'm going to do away with the toggle switch, or at least electrically do away with it. Eliminate it from the circuit. So the radio becomes a plug-in only radio, no battery supply. And but before I do that, while poking around in here, I think I had noticed that this terminal strip here, the screws come out of it. So the screw used to go in through a hole here, and the screw is gone. The thing about it is, this is an actual grounded terminal. If the screw were in place, this would be grounded solid to the chassis. And there's a terminal here that's wired. There's stuff on it. So there's stuff connected to a terminal that used to be screwed to the chassis. What happened there? Clearly there was a screw in here. Did somebody remove it on purpose? I'm really stuck now. I mean, let's see. There's another screw up here. Looks exactly the same. Same style. What else could the screw be for? Why would somebody, I'm trying to understand why somebody would take it out by accident, but so this could have been in the chassis. Somebody could have undone the screw thinking somehow that's going to release the chassis, and whatever happened here too. And then having done that, they accidentally ungrounded this, and the radio would probably not work after that. Or is that really the situation? Or was this never grounded? Same fat chance, man. I mean, the whole line's right up with the, So the real question is, what am I gonna do? What am I gonna do? I have to determine this point on the schematic, and then from there, is there another wire that's going to? Look, this capacitor's been replaced. There's a solder thing going on right here. This guy's been replaced. Or he's been cut and reconnected. Why would you cut something and reconnect it? Because you're testing the radio. You're cutting parts and then seeing what happens and making conclusions from that change. Well, there's a resistor on it, and two capacitors. Of course, they're going to ground, right? So these two capacitors are trying to fetch a chassis connection here, I imagine. I can identify these. This goes to this terminal. This one goes. Where's it go? It goes to a 2-pin. Okay, that's good. 2-pin. Oh, it's so dark in there. Let's get some light going here. Ooh. Pin number 1, 2. It's pin 3 on the 1T4, I think that is. Pin 3 on the T4. See if I can keep that straight. Oh, it's not no pin numbers. Okay, so pin 3 on a 1T4. Is it for sure a 1T4? Yes, it's 1T4. So we need to find out pin 3 on a 1T4. 4, pin 3 is the screen. So we have a capacitor going from the screen to ground. Screen on 1T4. 1T4, there's the screen. There's a capacitor right there. It says 0.05 and it shows it going to the chassis. I think that screw's got to go back in there. I think this has to be grounded, or this radio is never going to work. It almost looks like it must have been a screw and a nut. Here's a nice big screw. Is this the one? Did I do this? No, this is, what is this? Where'd this come from? Oh, this was holding in. Oh, that's what that other hole is up here, for crying out loud. I was holding this. Oh yeah, okay. Well, I'm going to find myself a screw. I'm going to bolt this guy down. And, see, it's got the paper in here, right? So it's on the paper side. So you really can't get any ground connection without a nut and a bolt through there. Very good. This is a part of my nut and bolt collection. You know, as you get older, you get more and more of these. And what I do is I save a lot of them. I store a lot of them with the nut right on it, because it's a real hassle to find an appropriate nut and bolt. How about that one? Certainly not a countersunk screw. I don't think many countersunk screws are machine screws. It's not going to go through. Oh yeah. There we are. Took my car to the mechanic to have 3 or 4 things done on it, and it's the first time in my life I have taken something to be fixed, because I fix most things myself, including my cars in the past, but this, no. Took it to have it fixed. Went and picked it up. Never talked to the mechanic, never saw the mechanic, never saw any work being done on it. It's the first time I've ever done that. Just take it in, other people deal with it, I jump in and drive away without knowing really who did what to what. That's the first time. Actually, it was kind of a good feeling in a way. Yeah, because all my life I drove pieces of crap vehicles because no money, raising a family and all that kind of stuff. No money. One of the vehicles I bought. Okay, I paid $300 for it. Went to see it with a mechanic. He said, "Look, he said, what's the guy want to sell it to you for? $300." He goes, "Well, buy it, because for $300 I'll get it on the road for you." And sure enough, $600 later, I was driving around in a car. But that car had to be repaired every week. That's what happens when you have cheap cars. Okay, so we bolted this guy in. Now I want to remove this. So why don't we just take a quick look at the schematic here and just be sure that there isn't something more to this. I imagine it's quite simple. What I'm imagining is, so here's the switch. There's the battery. So it's just a wire from the switch to the battery, from the battery up to here. And this side, the 90-volt battery, wire from the switch to the battery, and then from the other side of the battery. Wait a minute, this is going to the on-off switch. Oh, I followed the wrong wire here. Follow this wire. Well, wait a minute. So when you turn the switch on, you supply, well, that's quite a thing there. So this is connected to the negative wire, B minus wire, and this is to the chassis through this capacitor. This capacitor is probably this one. Okay. So this part, so it's a two-pole switch. So one pole is switching the 90 volts on, and there appears to be no switch on the 7.5 volt. This doesn't make a lot of sense here. Some of these radios, the high voltage battery had no switch on it. The voltage was always applied to the plates of the tubes all the time, day and night, 24/7. The only time any current flowed is if you heated up the heaters on the tubes. So if you don't turn on the heater supply battery, the B plus battery is not supplying any current anywhere. So you would tend to switch the heaters on and off and just leave the 90 volt battery connected. But this is doing the opposite here. This has got the 90 volts going through a switch. And how does it get up onto the plate? Come back through here. Oh my god, this is just crazy to look at. Okay, I'm going to stop for a while and study this to be absolutely sure I know what I'm doing, because it's not coming clear here. Okay, if we start with the on-off switch, and we look at this section of the on-off switch, when it's closed, it's putting, and this switch would be switched over here. I think this is why I'm having trouble with this diagram. The switch is showing just totally open, and you gotta imagine it being closed here. So with this closed, the ground comes all the way around to the bottom of the 7.5 volt battery, which is going to power. So it's connected to the same spot here from the supply. So I'm thinking if you're running from the supply, you should probably find 7.5 volts here, same as the battery. Just to carry on with that, that's dependent on this resistor and this one being what they're supposed to be. Now that's a big long resistor, and I believe they're pretty reliable, so we'll probably find that this is correct still. But if this isn't correct, then we could be putting too much voltage on these sensitive filaments, and I'm quite anxious about making a mistake here and burning out all these tubes, because I've done it once, and I don't like the idea of destroying 4 vintage tubes. So that's why I'm so cautious here. So if we did that, if I just made this connection permanent from here to here, just right on the poles of the switch even, and I cut away the wires from this part of the switch. They can't do anything from there. And where are the battery wires on here anyway? Shouldn't there be like a cable on this diagram, a cable kind of hanging out? Here they are. What are you talking about? That's another part that's probably confusing me, because they've got these batteries showing as if they're right in the schematic in the radio, you know. Would help me if they showed them down here with wires coming up. Yeah. Okay, I don't see any problem here, really. I really don't. Just cut away these wires and short this guy up, and next thing you know, we're going to have 7.5 volts here when we plug in. Okay, that's what I'm going to do. Well, cutting things, that sounds like the easy part of this kind of work. I'm trying to wiggle the wires, you know, through so I can see them. Here's one. This is one. one. Cut it right out of there. Cut it right. I'm going to cut them right near here. And trace them separately. That's 2. And then 4 of them up here. That's 3. That's 4. I should just pull it right out. If it doesn't pull out, I've cut the wrong wire. Why aren't you coming out? Just so tight in there. There we go. I just had to get a little more aggressive. Okay, that's out. Now the tails of the wires. It's going up to the switch. Way up in there. One wire, another wire, and there's a third one, this black one here. Where is it going? This disappears into a big pile. A big pile. Oh, it's just a mass of stuff in here. I cut it a little bit shorter and just leave it. Okay, it's not the best thing to do. There's a little tiny bit of copper showing there, but good enough for now. Okay, so that's, oh, this just broke. Oh no, this is not good. Things just went downhill big time. Uh-oh. Okay, so this is a new one on me. I just broke a terminal off of a tube socket and broke it flush with the tube socket. Oh no, right there. You can see the tube sockets riveted in place. Oh no. What are the chances that's a nothing terminal? You know, it's from wiggling this capacitor back and forth. In the back of my mind, I wondered. Should have wondered in the front of my mind. Doggone it. So which one's that? Where's the gap? Gap is up here. Gap is right. No, it's pin number 1. That's what it is. It's pin number 1 on what tube? Pin number 1 on this is the 5. This is the 3S4. Pin 1 on a 3S4. What do you do? Pin 1 on a 3S4. 3S4, pin number 1 is a heater pin. Well, we can't do without it. Oh man. New problem. Broken off flush. Totally flush. Oh no. Right flush. Even down a little bit inside. Okay, I have to stop and go away and think, because you know, the obvious simple statement that can be made is you need to change the tube socket. And I have lots of sockets. I've certainly got the sockets to do it. But that's an awful lot of work, and it just has even more risk while you're doing it that other things will go wrong. Never changed a socket in a radio before. Never broke a terminal pin off like that, or terminal off like that. Whoops. Yeah, just giving it a little bit of thought and considering how wonderful the weather is. I think that's it for today. Kind of not gone in the right direction here. We've actually gone in reverse, but I think I'm going to leave it for today and think about what to do about it tomorrow. Thanks for watching.